Hello. This presentation will be about some ideas I've had for moon-based construction. Some ideas I'm sure are already out there, but I've put them together with some of my own. There are a number of plans for this out there, but this is my 2 cents. Now then, there are 3 areas to look here: transportation to the moon, the machines we're sitting to do the work, and the actual design of the base, which goes hand in hand with the machines used. Things we need to remember is that we've been studying building moon bases for decades, and so all sorts of technical solutions are available for many of the problems people would point out. As far as launch, the Falcon Heavy rocket is really the key to the whole thing. While it's capable of 50 tons to low Earth orbit, this drops dramatically when you factor in the delta V needed to get to the moon. It would have worked with a Java calculator for delta V shows 5 tons to the moon would be about right. While with a Heavy costing 125 million at the top end, this gives 25 million per ton, and that will be our target for designing our machines. Getting down to the moon is another story. Reasonably well-built machines can handle some rougher landings than NASA is used to, and construction equipment like this will be built better than some of NASA's equipment. This is one of my original ideas. Instead of a parachute, we can use a rocket. Properly deployed, when fired, it'll provide a similar drag effect, allowing a soft landing without having to have a precision-guided rocket engine system, and will likely cost much less mass than some of the shenanigans NASA has used on various landers through the years. An underground base is a standard feature of moon bases, but the trench is a key feature here. It eliminates the need for another machine for vertical shafts, and is easy to do with the scrapers I'll discuss later, which are brought up for mining anyway. Fused regolith blocks provide building material, with inflatable habitats or polymer coatings providing sealing and part of the finishing. As noted later, hopefully only 1 or 2 machines would be needed specifically for base excavation. The construction and mining industries already use machines that do all of the tasks needed. They just need to be adapted for the environment. Remember, we're not making a little probe for Mars. We're building heavy machines for long-term use. Weight penalty must be balanced against having to ship a whole new machine up if the first one breaks. 1 ton isn't a hard limit to meet, since the machines are robotic and will be working around the clock. Some savings will be gained since most machines will be able to do more than one thing. You don't need to send both a mining scraper and an excavation scraper, for example, just one. The first machine would be a dozer and scout. This would survey the area using sensors to see below the surface and decide where the base and mines should be. Aside from sensors, this is a multi-purpose machine with arms and a dozer blade, and would do many other jobs after the base is established. The scraper is fairly fixed purpose. The conveyor type shown is preferable, since it does not rely on traction to dig, and that means you can get by with less mass. This machine would dig the trench for the base and mine materials later. Tunneling takes from the well-established mining industry, and this machine might end up breaking the bank on the 1-ton rule due to its size. A machine like the one shown would be ideal, as it would be able to cut a variety of different shaped tunnels, and might even end up serving other purposes if designed right. The only other mobile machine needed might be a compactor, if another machine can't be adapted. Roads, landing pads, and foundations would benefit from such treatment. Hopper trailers and such would be needed, but would be very light, being mostly empty space. Optimally, the stationary machines would be shipped with these, as being on a trailer on landing would make it easier to move them to their final position. Flagstones, wall blocks, and other construction parts would be made in a solar fusing machine based on designs like this one. Accuracy is plenty for work in rough construction. Regolith would be fused into ceramic panels and bricks to use in construction. Pressurized areas would be spray-lined with a thick polymer coating, or an inflatable habitat would fit snugly. Water, oxygen, rocket fuel, and other things will need to be made, and will require their own machines to make. The processes used in these machines may not be the same as on Earth. On the Moon, sunlight and its energy are plentiful, and efficiency takes a back seat to weight considerations. My cost estimates here are minimalist, but almost all of the engineering is application. Environment, materials, and technology are known. These might, however, be better served in an X-Prize style competition. The total cost I've calculated, a bit less than 500 million, is probably on the low end. If the Falcon family of rockets cost less than 500 million to develop, why not this? Not as many rockets will be blowing up for sure. This does not cover the cost of putting humans on the Moon either, but there has been plenty of talk about that. Thank you for listening.